Hello everyone. Today we are going to discuss about various computing paradigms. So before moving into what you mean by different types of computing paradigms, let me first explain what is a computer paradigm. So it is just the fundamental models that define how computers operate and solve problems. Each paradigm offers a distinct approach impacting the way we design and implement software as well as hardware. Coming to the more explanation, we can say that these are the approaches used to design, develop, and deploy computing systems, algorithms, and applications. So, it is much helpful in designing our hardware and software. So, there are various types of computing paradigms available, and which is the best is still a question. So, coming to the first one, that is traditional computing paradigms. As the name suggests, this is a traditional type of paradigm. Instructions are executed one after the other in a linear fashion, and but this forms the foundation of many programming languages as well as operating system. Although it's a traditional computing system, it is much used in our operating systems and all. Then what is its control, or what is the feature of it? It is having a single processor that manages the execution of all instructions, and it is very simple and efficient, but can become inefficient when handling complex or parallel problems. So the main explanation coming for tradition is that it can be used for simple programs, but coming to a complex process, it is not much useful. Okay, then one of the limitation is that it have limited resources. That is, it is having CPUs, cores, and memory, which are constrained the performance of certain applications. That means that if we don't have enough space or memory, we cannot perform any action properly. Therefore, it is the only limitation that we could say in traditional computer paradigms. Okay. So let me next explain what you mean by parallel computing paradigm. So the coming to its concept, it involves dividing a task into multiple subtasks that can be executed simultaneously on multiple processes. Okay, coming to its explanation, we could say that if we are having a very big task, executing it in one stretch is very difficult. But if we are dividing it into various subtasks, it may be easier for us to execute it faster. So that's the same idea that's using in parallel computing paradigm. So coming to its benefits, they can significantly accelerate the execution of computational intensive tasks such as scientific simulations, data analysis, and machine learning, because they are dividing all these tasks into various subtasks. So the execution can be faster as well as it can be done in an easier manner. Coming to its examples, we have multiple processors, GPUs, cloud computing platforms are the most commonly used examples of parallel computing paradigm. So I hope you understand about that. Next, we will move into distributed systems. So as the name suggests, we could say that these are distributed. Okay, this involves distributing tasks and data across multiple interconnected computers, and this allows for greater computational power and scalability. So resource sharing, distributed systems enable resource sharing, allowing different computers to access and utilize resources from other systems. So if we are coming to its features, one of the main feature is that it can be helpful to utilize resources from various systems. Okay, another feature is that it has fault tolerance. Okay, they ask perform or they can perform tasks across multiple computers. That helps improve fault tolerance, making the system more robust to failures. Okay, we know that if we are making so much mistakes in a system, it is not efficient, it is not considered as an efficient system. So in the case of a distributed system, it is minimizing its fault tolerance. So the example includes distributed databases, cloud computing platforms, then peer-to-peer networks are the most common examples of distributed computing systems. Okay. Next, we will move into grid computing. So as a technical student, we could say that grid computing as well as distributed type of computing is one of the major type of computer paradigms that we are going to discuss in our lives. So here, coming to grid computing, it utilizes a collection of geographically distributed computers to solve complex problems that require significant computing power. That means they are selecting some of the resources, and they are checking whether it have to be happened in just in a one stretch or we have to divide it. So it has a set of organizations to check whether it is to be sold in a single stretch or it have to be divided. And these computers can be from different institutions, organizations, or individuals forming a virtual organization that shares resources. Okay, we are accepting the resources from different sources, and we could combine it to form a single operation. The applications where grid computing is used is in scientific research, drug discovery, and climate modeling, where large scale simulations are necessary. So one of the advantages is that we can include or we can use grid computing in very large scale simulations. Next is cloud computing paradigm. Users can access and use computing resources such as servers, storage, and software on demand without the need for any physical infrastructure. So there is no any typical physical infrastructure involved in the case of cloud computing paradigm. So here all the things are coming under a network. Okay, or we can say that it's virtually available. Then coming to its scalability, cloud services can easily scale up or down to meet changing demands, providing flexibility as well as cost optimization. One of the major advantages of cloud computing is that pay as you go. If you are using more resources, then we need to pay. If you are using limited resources, we have to pay less. That is one of the major advantages we can say in this case. Okay. Next, we are coming into quantum computing paradigm. It is simply like that leverages the principle of quantum mechanics to perform computations in a fundamentally different way from traditional computers. So it's just a different way to approach computing paradigms. Coming to its superpositions, we have qubits, the basic unit of information in quantum computing that exists in multiple states simultaneously, enabling parallel computations. The entanglement and quantum gates of quantum computing is also different. That means these are the terms that is included in this types of computing paradigms. So if we are coming to the various applications of computing paradigms, firstly, if we are saying about traditional computing, it includes its major application like desktop, mobile apps, embedded systems, as well as general purpose computing. In the case of parallel computing paradigms, it is mainly used in scientific simulation, data analysis, machine learning, image processing, as well as video editing. Then coming to the distributed computing, it includes cloud computing, online gaming, e-commerce, social media, and large-scale data management. Grid computing involves that is mainly used in scientific research, drug discovery, climate modeling, as well as high-performance computing. And quantum computing is mainly used in material science, cryptography, optimization problems, and financial modeling. So from this video, I could say that I hope you understand that these computing paradigms are very much important in our day-to-day applications, as well as in discovering different types of climate, weathercast, and all these things. So without this computing paradigms, we cannot move further. This is the main thing to importantly note here. Also, we have coming to grid computing as well as distributed computing. They are distributing their works into various types, and as well as they are improving the way how to manage a very large resource to subtask, and we are just arranging those all subtasks to form a common and joining all this to form a lab. I hope you understand about the computed paradigms. That's all about this. Thank you.